Without any further ado, I'm going to turn over to you, Philip. Take it away, and if you want to share your screen with us, looking forward to your presentation.
Great. You should be able to see my screen, Len, can you?
We see it if you want to go to full screen.
Yep.
Perfect.
Yep. Great. Thanks so much. So thanks for inviting me along. Clearly I didn't understand the brief quite so well, Len, because I'm going to give you 3 lessons all myself, but let's call this one big lesson and three components. So I'm going to start off, these are my disclosures. I'm going to start off just talking about the immune system first of all, because I think it's really important we understand what it is we're talking about when we're talking about immunity in the context, let's say, of supplements or functional foods. So as you know, the immune system is what protects us against harmful organisms. We call these harmful organisms pathogens, dangerous bacteria, viruses, and so on. We know that a well-functioning immune system is key to providing robust defense against pathogens, because people with weak immune systems are at increased susceptibility of infections and of infectious diseases becoming more severe, even fatal. The 4 general functional features of the immune system are listed here, and these could all be separate targets, if you like, for particular nutritional or non-nutritional interventions. Firstly, the immune system acts as an exclusion barrier to keep pathogens out. Secondly, it's able to recognize foreign invaders and identify them as being harmful or harmless. So it can recognize and identify. It can eliminate those invaders that are identified as being harmful. And then it has a memory component, which means actually over your entire life, you remember your immunological encounters, so you mount better responses if you're reinfected. The memory response is the basis of vaccination. So the immune system is pretty sophisticated. Obviously, it's complex. It can recognize, identify, eliminate, and remember. So this complexity is sort of contained within all the different components that go to make up the immune system. In general, we divide these into innate immunity and acquired immunity. There are cellular components of both innate and acquired immunity, cells like natural killer cells and the phagocytes in innate immunity, and the T lymphocytes and B lymphocytes in acquired immunity. Innate and acquired immunity talk to one another, they communicate. Each of the different components has its own role within the immune response, but they have to be working together for our immune system to work properly. Again, there are lots of targets here, individual cell functions, individual cellular responses. But stepping back, we know that weak immunity gives us poor defense against harmful organisms that results in infections. And of course, infections are harmful. We've seen in 2020, suddenly, that weak immune systems were exposed as a major public health challenge in places like North America and Europe, where we weren't so worried about infectious disease anymore. Going back 100, 200 years, infectious disease was a big problem globally, but we'd got over that through other interventions like increased hygiene, sanitation, use of vaccines, and so on. But anyway, 2 years ago, this became a big problem for us wherever we were, as you all know. Of course, last year, multiple COVID-19 vaccines became available. These help us a lot, of course, they work very well, but keep in mind that vaccines work by inducing this memory response. They work by helping the immune system. And we know from other settings that vaccines often work poorly in people with weak immune systems. In other words, they don't work so well in the people that need them the most. So anyway, thinking about immunity is ongoing, and it's part of the new normal, as we just heard, I think. So we need to think about the factors that influence our immune response. Some of these are things we can't do anything about: our genetics, our infection history, other illnesses, medications, and so on. But there are lots of lifestyle factors that impact our immune response: cigarette smoking, alcohol consumption, being physically fit, stress, body fatness, as I'm going to talk about, nutrient intake, and the gut microbiota. these all have differential effects on the immune response. So if we think about lifestyle factors, on the left, I show those factors that weaken our immune response: stress, sleep deprivation, smoking, excess alcohol, obesity, and a poor diet. And on the right, lifestyle factors that support our immune system: being physically fit and having a good diet. Now, frailty is the result of loss of lean muscle mass, often in the combination with inflammation. And it turns out, this is my first lesson, that frailty increases risk of severe COVID-19. So this is a meta-analysis of different studies comparing frail and not frail older people, looking at risk of mortality from COVID-19. And you'll see, however the data were used as odds ratios or hazard ratios, there's increased mortality, about twofold increased mortality on average in frail older people compared to non-frail older people. So here's an image I drew of the frailty cycle, and I placed nutritional inadequacy at the center of the frailty cycle. So this could be low intake of energy, poor protein, could be lack of micronutrients, often in combination, driving weakened immunity and gut dysbiosis, predisposing to infection, also driving inflammation and oxidative stress. That causes loss of lean mass. Now we have functional decline, immobility, poor dentition, all of those things reinforce the nutritional inadequacy. Out of all of this comes illness. Of course, the illness also can create the nutritional inadequacy. So this is the frailty cycle that predisposes people to more severe COVID-19. So I think it's important to improve immunity in people who are frail. So you might want to think about high quality protein sources, micronutrients, maybe other essential nutrients like omega-3 fatty acids, and also thinking about the gut microbiota as a target. These are interesting things to think about in that group of people. But of course, in the population, it's important for people as they age to maintain or regain muscle mass to prevent or reverse frailty. So here, physical activity, protein, particular amino acids like the branch chain amino acids, and maybe other important nutrients, particularly vitamin D and omega-3 fatty acids. So you could have a combination of vitamin D, omega-3s, branch chain amino acids, and some physical activity, and that could really help with the healthy aging of the musculoskeletal system to put off the onset of sarcopenia, loss of lean mass, leading into frailty. I think my second lesson is that obesity predisposes to severe COVID-19. Again, this is a meta-analysis looking at obese versus non-obese individuals, showing that those with obesity have increased risk of severe COVID-19, increased risk of ARDS, increased risk of hospitalization with COVID-19, increased risk of need for mechanical ventilation, and increased risk of ICU admission. So being obese is bad news for COVID-19 compared to not being obese. These are data from all of the data points in the United States from March to December 2020, showing that although obesity increases risk compared to not being obese, showing that for these severe outcomes, hospitalization, ICU admission, need for mechanical ventilation, and mortality, there's actually a continuum. So it's not simply obese versus non-obese, there's a continuum with body mass index. So I think it's important to improve immunity in those people who are already obese. And here, micronutrients, other essential nutrients, and again, things that target the gut microbiota could be really important. But of course, it's important for us to promote weight loss, weight maintenance, and to prevent weight gain. So again, obviously, physical activity and exercise are really important here, but also there's a role for low energy, but essential nutrient-rich foods. Because I think one of the problems is these energy-dense food sources that are actually micronutrient and other essential nutrient poor. So we create individuals who not only are obese, but they're micronutrient deficient. and they have gut dysbiosis as well. Then the third lesson, and this tacks back to, I think, Dan's talk, is that micronutrients and also other essential nutrients are vital for the immune system to function. So this is a figure, maybe it's a little bit hard for you to see, taken from this really nice review that was published actually just before the coronavirus pandemic, which is a comprehensive review of micronutrients, immunity, and infection. And what this figure captures is the different components of the immune system. These are the innate immune components. This is the inflammatory response. And then these are the components of acquired immunity. And then in these gray colored circles are all of the micronutrients that support that aspect of the immune response. So for example, for T cell mediated immunity, we see vitamins A, D, C, E, B6, B12, and folate, and zinc, iron, copper, and selenium are all vital for supporting T cell function. So lots of micronutrients are important to T cells, but we see the same micronutrients repeated time and time again right across the breadth of the immune system. So vitamin D has been, I think, to the fore during the COVID-19 pandemic. This is a meta-analysis reporting that vitamin D deficiency is associated with increased risk of severe COVID-19. So people who are vitamin D deficient were more likely to have severe disease. This is zinc, showing that zinc concentrations, let's just look at the right-hand side here. These are zinc concentrations in yellow in healthy controls, and the other two sets of data are people who are hospitalized with COVID-19. So zinc is lower in people hospitalized with COVID-19 compared to controls, and it's lower in those who unfortunately died compared to those that were discharged. Again, on the bottom left, zinc status is lower in those with severe COVID-19 compared to mild or moderate COVID-19. And in the upper left, zinc is lower in patients with COVID-19 compared to healthy controls. Then selenium, a similar picture here, two markers of selenium status, blood selenium or plasma selenium and blood selenoprotein concentrations, again showing that selenium status is lower in those hospitalized with COVID-19 compared to controls, and it's lower in those who died compared to those who were discharged. So if we step back and look at what we already knew about nutrients and the immune system, the fat-soluble vitamins, A, D, and E particularly, and probably vitamin K as well, the B vitamins, including folate and vitamin C, lots of minerals, particularly zinc, copper, selenium, and iron. These are all fundamentally important to the function of almost every different type of immune cell. Also, lots of amino acids are important, essential amino acids, but also some non-essential amino acids are really important in the immune system, glutamine and arginine, the sulfur-containing amino acid, the essential fatty acids, the omega-3 fatty acids. These are all really important. Now, if we go beyond mainstream nutrients and think about other dietary components that might be important, many compounds of plant origin seem to have roles, at least in some components of the immune response, particularly maybe controlling adverse inflammatory responses. So here I'm thinking about phytochemicals from fruits, vegetables, berries, and so on. The beta-glucans, particularly the yeast beta-glucans, the beta-1,3 and the 1,3,1,6 glucans seem to be very important for what's called immune training. There's good data there, at least in model systems, some data in humans, particularly looking at respiratory infections with the beta-glucans. And I think the gut microbiota was touched on a little bit towards the last talk, maybe in the discussion there, that prebiotics and probiotics impacting gut microbiota are really important in supporting the immune response and helping control inflammation. So I think actions to support a healthy immune response would be to maintain and achieve, or achieve and maintain maybe, a healthy weight, keep physically fit, reduce stress, sleep well, keep hydrated, and ensure an adequate intake of all essential nutrients. And I've mentioned quite a number of those that have been investigated with regard to immunity, and particularly during the COVID-19 pandemic. And I think also adopt a diet that promotes a healthy, diverse, gut microbiota. Lots of plant-based foods, maybe some other prebiotics that are available. And of course, probiotics will also have a role as a sort of a quick fix for the gut microbiota. Thanks very much for your attention.
Philip, thank you very much. It's a lot of ground to cover, a lot of nutrients and a lot of big science. I've not heard let's say noise, but that's the wrong word. But the fanfare around selenium to the extent that you placed it here. So why do you think that is?
Yeah.
And it sounds like there's a direct correlation there.
Yeah, that's a great question. So I think selenium is one of the underexplored of the trace elements. So, you know, zinc gets all the attention. We just heard that from Dan, I think. But I think selenium is much under-recognized. Now, there's a lot of really good basic science work showing that selenium deficiency increases risk, particularly of viral infections. And in fact, it permits viruses, including the influenza virus, to mutate and become much more stronger. And I think this is really interesting in the context of emergence of coronavirus variants. So the feeling is, as far as other viruses is concerned, is that selenium deficiency creates an environment that permits viral mutation. So I think that's one of the big interesting things around selenium. You're right, it's underexplored, but I've been talking about it actually for 2 years now in the context of COVID-19. Maybe no one's listening to me, Len, I don't know. But I think it's an interesting one. And of course, in Europe, we have selenium poor soils. In North America, you guys, your soils have more selenium than we have here in Europe. So selenium insufficiency, let's say, is a problem in Europe, and maybe it's not such a problem in North America. Maybe that's important to consider as well.
Excellent. So we've got a generally industry audience here with suppliers and brands and retailers and platform service companies. There's a lot of information. There's a lot of noise out there. How do we do the best job as stewards of the science-based and emerging science and give good guidance to our constituency? What's your advice for us?
I think that's a really good question, because I presented data on vitamin D, zinc, and selenium, which are all associations. That low status is associated with poor outcome from COVID-19. What we really need, I mean, people consider that to be a low level of evidence because it's just association. It doesn't show cause and effect. And there are actually for vitamin D, there are hundreds of papers now. For selenium, there are a few. For zinc, there are quite a number. But what we really need is trials. We need trials to see if these micronutrients can protect people. And if you're interested in treatment, if people are already sick, we need trials of treatment. So I think we just need to sort of keep our feet rooted in reality. Of course, you know, 2 years ago, we hadn't heard of COVID-19. So an awful lot of science has been done in the meantime. And I think we sort of just need to like take a breath and look for where the really good studies are and focus on those for the evidence.
It's a great cautionary response as we become and maintain being responsible stewards. Philip, a great presentation, lots of ground to cover. These are being recorded. They'll be available on demand.